On the left side of your screen, you will see our exponent rules, both as in math terms and then in words. You should also have a completed version of this. On the right side is our 6.1 notes. The 6.0 notes go over all of this, but without the fractions, so I thought we would stick with a little more difficult one. I'm going to really quickly talk about the rules first down here with the in words part. So product of a power. When multiplying like bases, you add the exponents. So if we look down here, remember multiplication can look different ways. So two parentheses like this, bases are the same, that's multiplying. If you have a dot in between, again, the same base twice, that is multiplying. So in both of these examples, we are adding those exponents. You have fraction buttons on your calculator, so that can do that for you. Desmos can also add fractions. So if I were to pull this up and then type in 1 over 2 plus 1 over 3, change it to a fraction, we can see 5 over 6. So the base is not changing, we're just adding the exponents together. The next thing we have is power to a power, which is on page, what page is this? Sorry. Page 7 of your notes, we have power to a power. So power to a power, there's one base. So we have the variable once. We have the exponent we have an exponent 2 times. So one base, 2 exponents is when we multiply the exponents together. Another rule we have is that if there's no addition or subtraction inside the parentheses, we raise everything inside the parentheses to the exponent on the outside. So a to the second and then to the fourth. We have a one time, but that 1a has 2 exponents. So 2 times 4 gives you 8, and then 3/8 times 4 is 3 over 2. And we're just doing the same thing over and over again. So even if we have one fraction and one not a fraction, that x happens one time. It is a power to a power. We multiply the exponents. This is different than up here. So if we compare these like B problems, that a was happening one time, 2 exponents. But here the x is happening twice. The same base is happening twice. Those bases are being multiplied. We add the exponents. The one base has 2 exponents. We multiply. The next thing is if we divide like bases. When we divide like bases, we subtract the exponents. So since we are dividing the bases here, we subtract the exponents. And that kind of leads us into our negative exponent rule. If we have a negative exponent, we have to move it to the other side of the fraction. So let me pull up a more complicated problem real quick. So if we look at this problem right here, hopefully you can see my cursor. So everything inside the parentheses got raised to the power 2. So 3 got raised to the power of 2. X was already being raised to the power of 5. Then it got raised to the power of 2, which means we had to do 5 times 2 to get 10, because that one base had 2 exponents. Same thing with the y, negative 2 times 2. Now, 3 to the power of 2, you can put in your calculator and get 9. So 3 to the power of 2 means 3 times 3 to get 9. X to the 10th was good, had nothing to combine with because there's no other x's. But then the y had a negative exponent, so we had to make a fraction and then move the y, and then it became a positive 4. So just a couple more exponent examples. One last thing I didn't talk about was 0 exponent rule. Anything to the power of 0 is 1. I don't think I have any on here, but in the 6.0 notes we did have an example of we had a whole bunch of stuff raised to the power of 0, so it was equal to 1. One last thing that I want to remind you about, and then I know you probably won't watch much longer, but if you look at number 7 from your 6.0, x has a negative exponent. 7 doesn't. So 7 stays where it's at. We make a fraction, and the x moves to the bottom. Okay, so these are your exponent rules. I like to look at it in words, but sometimes the math rules can also be really helpful. So whatever works for you, go with it. Practice is your best friend here. Do your quiz review a couple times if you're studying for the quiz. Just practice.